The Sun is 4.6 billion years old, and some stars are up to 10 billion years old. So, do you know what stars have gone through in those 10 billion years? It all begins in a place called a molecular cloud, made mostly of hydrogen and small amounts of heavier elements. Within these dusty clouds, deep in the cosmos, molecular clouds drift silently, like oceans in space, waiting for the spark of life. Suddenly, perhaps triggered by a nearby supernova or gravitational ripples from neighboring stars, this quiet molecular cloud stirs to life. Material in the cloud gathers under gravity's pull, forming dense pockets of gas. As the gas builds up, pressure and temperature inside these pockets steadily climb. It's like being in a sealed car during a summer day. Rising temperatures fuel energy, and molecules race faster. When the temperature hits about 10 million degrees, one of the universe's grandest spectacles unfolds. Hydrogen fusion. Hydrogen atoms, under extreme heat and pressure, fuse into helium, releasing vast amounts of energy. This energy powers the star's life. And it's the light we see twinkling in the night sky. Through this process, a new star is born. Over time, the protostar's core grows hotter and denser, until it's ready to sustain hydrogen fusion. This marks the star's entry into its stable main sequence phase, where it will shine for billions of years. When its hydrogen fuel runs low, the star enters middle age. Its core contracts, while its outer layers expand, turning it into a red giant. At this stage, the star swells dramatically in the red giant's core. Helium fusion kicks off, giving the star a new lease on energy. During this phase, the star undergoes complex changes, possibly pulsing or shedding mass. Along the way, it forges heavier elements, like carbon and oxygen. If the star is massive enough, it may end in a supernova explosion, closing its life with a cosmic fireworks display. The energy and material it releases ripple through interstellar space. But this explosion isn't the end. It's the start of something new. A supernova unleashes immense energy and heavy elements, essential building blocks for new stars. The star's remnants mix with surrounding gas and dust, forming a rich nebula. This nebula, or molecular cloud, is a stellar nursery. It fosters the birth of new stars, providing the raw materials they need. Within the nebula, matter is unevenly distributed, creating pockets denser than their surroundings. These dense regions collapse under gravity, gradually forming what we call protostars. Protostars pull in surrounding material, growing larger and hotter. When the core reaches extreme temperature and pressure, it ignites a fusion reaction. Hydrogen fuses into helium, releasing a surge of energy. This heralds the birth of a new star. For less massive stars, too small for a supernova, they may quietly fade into white dwarfs. But if they're massive enough, they might collapse into neutron stars, or even enigmatic black holes. In this vast universe, every star is a miniature tale of life. Their birth, growth, and demise mirror our own existence. Have you ever wondered, if you had such a long lifespan, what would you most want to do?